Okay, this video is going to go through and show you the notes for 7.5 and 7.6. We talked about this at the end of the class on Wednesday, and so I'm just going to go through a couple examples to refresh your memory. Let's start with the example right here with 5 to the 2x power equals 130. And if you remember exponential equations, we want to try to get the bases to be the same, but the problem is you can't get 130 here to be a base of 5, okay? So if you remember, we had the question, how are we going to get that 2x out of the exponent? Well, we're going to use our log properties. Okay, so what I'm going to do here is I'm going to take the log of 5 to the 2x power, and if I do it on the left, I have to do it on the right. So I'm going to take the log of 130. Okay, now, by taking the log of both sides here on this exponential equation, this allows me to take this 2x and move it to the front. So it's going to be 2x times the log of 5 now equals the log of 130. And now what that allows me to do, get the exponent out of the exponent, get the x out of the exponent, and move it out front. And now I can try and solve for x. What I'm going to do now, divide by the log of 5. And so these log of 5s are going to cancel out. And I get 2x equals, I've got the log of 130 divided by the log of 5. And I should get, round everything to the nearest hundredth, so 2 decimal places, 3.02. Okay, and then I'm going to take that answer, 3.02, and we're going to divide that by 2 to finish it off. And x is going to equal 1.51. Okay, so that's an example of solving an exponential equation. Okay. Now, let's take a look at a problem. And I'm going to change this problem down here in the corner. This 7 to the 4x. Let's make this 7 to the 4x minus 3 equals 797. Okay, so let's cross this guy out. And I just want to show you a problem with an exponential equation where you have to get the base by itself. So what I'm looking at here is, I'm looking at this 7. This 7 is the base. This is extra stuff. And so I got to get rid of this before I can do anything here, okay? So what I'm going to do now to get rid of that thing is I'm going to add 3. And so now I have 7 to the 4x power equals 800. And now that I have the bases by themselves, I'm going to take the log of both sides. So I have the log of 7 to the 4x power equals, and one of the biggest mistakes that you'll make, that you always forget, is to do the log of both sides. So this is the log of 800. Now again, this exponent is going to move down. So this is 4x times the log of 7 equals the log of 800. Okay, then I want to solve for x now. So I'm going to divide by the log of 7. So as I divide by the log of 7, these guys go away. 4x equals the log of 800. And I divide that by the log of 7. And I get 3.44. Around to the nearest hundredth. Okay, and then I'm going to finish this guy off and divide by 4. And now x is going to equal 3.44 divided by 4, which happens to be 0.86. Okay, so those are 2 examples of solving exponential equations. Okay, exponential equations. Now, if you remember, I went through this example the other day with E. Remember with E, get rid of the 2, get rid of the 4, and then you're going to use the natural log, which is the ln button. Okay, All right, now let's solve log equations. So solving log equations is you've actually done this. Because if you remember, when we did evaluating, you actually did this. The difference is, in the past, your x was always in this spot. Well, now your x is not there. Okay, your x is now inside the logarithm part of the equation. Okay, so what you're going to do, get everything away from the log. So if there's anything in front, anything behind it in terms of back here, where like if there's a plus or minus, or if there's a multiplication here, you want to get rid of all that stuff. Get the log by itself, and then once you get the log by itself, we're going to change forms. Now, if you remember, if there's no base on a log, your base is 10. And so what I'm going to do here is I'm going to change forms. I get 10 to the second power equals 4x minus 3. Well, 10 to the second power is 100. And now it's about solving, getting x by itself. So I'm going to add 3. And I get 103 equals 4x. Then I'm going to divide by 4. And so when I take 103 and I divide it by 4, I end up with 25.75. And I will tell you that is your answer. Maybe. You have to check these ones. Because if you remember when we talked about this in class the other day, if on your calculator you type in log and you put a -1 in, you get an error. Why do you get an error? It's not possible to have a negative number out of an exponent. So that'll never happen. You'll never have a negative number inside that parentheses. So what I'm going to do now, take this 25.75 and plug it in for this x. So I take 25.75 times 4. That gives me 103. 103 minus 3 is 100. Is that number positive? If that number's positive, this guy checks out. Because I can take the log of 100. And on your calculator, if you take log of 100, you'll end up with this guy right here. You'll end up with 2. So this answer here checks out. You always have to check your answer when you're doing logarithms. Okay, so get to an example like this one here. Again, there's no base, so automatically your base is a 10. Going to change forms. 10 to the negative first power equals 3 minus 2x. Well, 10 to the negative first power on the calculator is 0.1. So now I'm going to subtract 3. 0.1 minus 3 is negative 2.9. And I got negative 2x. Now I'm going to divide by negative 2. And when I take negative 2.9 and I divide it by 2, I end up with 1.45, maybe. Got to check it. Okay, so on here, 2 times 1.45 is 2.9. 3 minus 2.9 is 0.1. Is that number positive? That answer is yes. And if you want to on your calculator, you can take the log of 0.1. You'll get negative 1. This answer checks out. Okay, so those are two of the kind of the simpler examples of solving logarithms. Now, let's go down here to this one where we've got natural log. Okay? And we also have a problem where we have an exponent in here. So, I have the natural log of x minus 3 squared equals 4. The difference on this one is the fact that we have a squared term. Well, I'm not going to mess with that squared term. What I'm going to do, I'm going to take this squared term and I'm going to move it down front. Use my logarithm properties. Okay, now, using my logarithm properties, I got to get this natural log by itself, so I'm going to now divide by 2. Get that exponent out of there. So I have the natural log of x minus 3 equals 2. Now, if you remember, natural log is log base e. So what I'm going to do here now is I'm going to change natural log to log base e. And I'm going to now change forms. E to the second power equals x minus 3. On the calculator, e to the second power is 7.39 equals x minus 3. And if I add 3 to each side, I get x equals 10.39. Okay, now, if I take 10.39 and I put it in for x, 10.39 minus 3 is 7.39. Is that number a positive number? Absolutely it is, 100%. So then I don't have to worry. This guy checks out. Okay, so you're probably wondering, well, what's it going to look like if I have a problem and it doesn't check out? Like, what will happen here? Okay, so on this one, let's go down here and let's go to an extra page here. All right, if you haven't added your extra pay or just put this on a blank example, I'm going to just call this example number 1 for the purposes of the problem here. Let's go log base or log of x minus the log of, let's go x minus plus 8. And let's go equals let's say 1 for now. Actually, let's go with, instead of 1, let's go with 5 for now. Okay, so notice on this problem, excuse me, a little bit different because now I have 2 logarithms. Well, I can't solve this log equation with 2 logarithms. I can only have 1 to solve it. So what I have to do here, I have to condense this. So I have subtraction. That tells me when I have subtraction, I know that makes division. So this is going to be x over x plus 8. That's why we learned condensing. Okay? That's why we learned condensing. As a matter of fact, just for the purposes of this problem, let's change that 5 back to a 1. I was just trying to, make this up off the top of my head. So let's change that 5 back to a 1. All right, now I'm going to change forms. I have a base of 10 down here. So I have 10 to the first power equals x over x plus 8. Okay, so 10 to the first is 10. What are you going to do to solve? We got to get x by itself. Well, in order to get x by itself, I got to multiply by x plus 8. So I'm going to take this guy over here by x plus 8. Distribute the 10. 10x plus 80 is going to now equal x. And I want to solve for x. So subtract 10x. And now I get 80 equals negative 9x. So when I solve, I'm going to take divide by negative 9. And x is going to equal, if I take 80 divided by negative 9, I get negative 8.89. Okay, now, if I take this answer and I plug negative 8.89 in, on your calculator, take the log of negative 8.89, what's it going to do? Well, it's going to give you an error because you can't take the log of a negative number. That means, sorry, you don't work. And in this case right now, my answer is no solution because I don't have any other number to work with. Okay. So that gives you an example of one where you check it and it doesn't work. Okay. All right, so the examples that I've shown for you here on solving log equations and solving exponential equations, you should be able to use this and be able to figure out most of the problems that I have selected on the practice.